Are you sick of being out of shape? Are you ready to change your life? You've come to the right place. I'm going to show you the physics of weightlifting and how this science affects your weight loss. Newton's first law of motion states that an object in rest will stay in rest, just as an object in motion will stay in motion, unless acted upon by an unbalanced force. If no one is trying to pick up the weight and it is resting on the floor, the weight will continue to rest on the floor. It will not just suddenly be thrown into your arms. In order to get the weight to move, we must apply an unbalanced force. This is where your weight loss comes in. The more mass of the weight you are trying to lift, the more inertia required to lift the weight. This means you'll need to apply a stronger lifting force and thus gain stronger muscles. Newton's second law states that acceleration is directly proportional to net force. Net force is the sum of all the forces acting on a system. When the mass of an object increases, the acceleration of the object also decreases based on Newton's law of net force equals mass times acceleration. How does this apply to weightlifting? Well, many times bodybuilders or people just trying to get in shape will increase the mass of the weights they are lifting. By doing so, the mass is increased and so the acceleration will decrease. In order to move the weights the same distance then, the weightlifter needs to apply a greater net force to balance out the equation. They are thus working harder to complete the same amount of reps. You may think that while you're weightlifting, the only force being applied is the force of you lifting the weight. However, according to Newton's third law, forces always come in pairs, so when you're weightlifting, each action force has a reaction force, or a pair. For instance, when you lift the weight, there is a normal force of you on the weight pulling up. On the other hand, there is also a normal force of the weight on you pulling down. These two forces are equal in magnitude, but opposite in direction. The normal force of you on the weight up is equal and opposite to the normal force of the weight on you down. Work and weightlifting. When we lift weights, there's work present. Gravity is pulling on the weight, and we need to apply a pulling force greater than the gravity in order to lift the weights. Because there is motion, and the direction is along the axis of motion, we can confirm that work is being completed. If we wanted to calculate the exact value of this work, we could use the equation work equals force times displacement. For example, if I was pulling the weights with a force of 10 newtons and I raised them about 36 inches above the ground, the value of work would equal 360 joules. Now the energy of weightlifting. Work transforms into energy, and in this case it is removing energy from the system because we're working out. After we lift the weights off of the ground, they are no longer at ground level, and thus gravitational potential energy is present. Using the equation gravitational potential energy equals mass times gravitational acceleration times height, we can determine the amount of gravitational potential energy being used. Let's say this weight has a mass of 10 grams, and I'm raising it again 36 inches above the ground. We know that gravitational acceleration always equals 9.8, so the equation becomes GPE equals 10 grams times 9.8 meters per second times 36 inches. So, the gravitational potential energy is equal to 3,528 joules. So right now, there's 3,528 joules of energy being created as I lift these weights. Have these videos helped you to lose weight and understand physics better? Then give us a call at 1-800-PHYSICS.